160 plus degrees.
160 plus degrees. Jesus Christ. I wouldn't be surprised if this just burst into flames. So today we're going to be going back and we're going to be looking at what we done last week, but we're going to be doing it with a slightly different spin because the effects that we actually got in the end were quite poor, to be fair. So last week we had a normal ye olde style cable drum and we literally just had a melting and a very minor pop.
160 plus degrees.
So you can see in there just where the cables just fused together, and it was very little. A couple of people did comment that you could see the blowout on the video, which we did see once we'd obviously filmed it, but we didn't really see on the day. So anyway, so that was plants. This week we're going to be doing exactly the same. Well, but last week, to be fair, we didn't do it correct. What we should be doing with this is a slightly longer, slightly slower draw on the power, because these things can happen over time. So we had lots of people commenting last week that this had happened to them previously. Someone had plugged in a small heater, and we've got many big heaters, and we overloaded it last week. That was we kind of done the experiment a little bit too fast. Whereas realistically, as I said, you'd have one 300 kilowatt heater that would slowly trickle, slowly heat up over time, and with literally one heater on it, it could potentially cause a fire and a little explosion like we had last week. But we're going to hopefully this week have a little bit of a bigger explosion. We are cheating in a very slight way. So we have got slightly thinner cable. This is 0.75, but it's because we want to show the effect of these two, which we didn't really see again last week. We did get a bit of resistive losses and build up because all the cables were all bundled together, which it is in any sort of cable reel. All the cables so bundled together that the resistive losses, the temperature can't escape. But we didn't really get much proximity effect, or that we could see in a visual way. So this week, we are not going to have a really deep amount of cables. We're going to have one layer of cables. We've got 8 meters of cable, or 8 meters of cable, and we're going to load it up till it's about 70 degrees. So we're only going to load it with possibly 1 to 2 heaters, and then we're going to leave it for about 10 minutes. Obviously, we'll cut the video, and then we'll see exactly how long we can keep this cable just running at an optimum operating temperature. So that we're not expecting to blow out, we're not expecting it to melt. We just want it to heat up and just sit there like it would do if you had an extension reel fully unwound. Then what we're going to do is, with the same amount of load, we're going to coil this cable perfectly straight across. Now this 8 meters fits, it doesn't look like it would do, but this 8 meters fits perfectly across there. So we'll just have one layer the whole way along, and we will then hopefully see more proximity effect than we do resistive losses, because although that there will be a little bit of resistive losses because the cables are next to each other and they're obviously sat on something, so they've only got one way for the temperature to go. The magnetic effect of the proximity effect, where you've got the electromagnetic field going round and round next to each other, we should see the increased temperature in the cable with the same load that was perfectly fine to sit on this cable for 10-15 minutes. Hopefully it will go pop in a lot bigger way than it did last week, because we'll be able to see it because there's only one layer. We are also cheating in the way that we have got both the neutral and the earth connected only to the neutral. Obviously the earth is a safety circuit, or a safety part of the circuit. We're not worried about safety, we're just looking for the maximum effect. So we're not going to try and blow out the cable out to start with. What we're going to do is we're going to do an actual science experiment, which is slightly different than what we've been trying the last couple of weeks. But we will try and probably end with a slight explosion, or it might even explode within this. But I think that what we need to do is actually try and prove the effect of the proximity effect, as I said, without as much resistive losses, because we haven't got the cables all bunched up together. We've got the cables side by side. So hopefully the magnetic effect of proximity effect will actually heat up the cable significantly. So we don't want to overload it. We know we can blow a cable up. We know that from the last previous few videos. But what we want to do is, if we can actually get proximity effect to show its effects. We'll load this up with about 18, 19 amps, which we know it can take. We have got 8 meters this week. The other week when we were trying to overload it, we were only overloading 1 meter, which is obviously a lot less resistance. In fact, 8 times less resistance than the 8 meters that we got. So we're going to have a little bit of heat build up from the cable and the length of the cable, because obviously resistance increases heat, which increases the temperature, because the heat is temperature. And then obviously we'll get the 150 degrees to melt this eventually when we do want it to go bang. But we're going to load this up with 19 amps now. We're then probably just going to let it sit there, because we know that we've got 19 amps of stable load that won't trip out or won't keep tripping out because it's got a thermal overload or a thermostat on it. And what we'll do, we'll leave it for 10 minutes, get a temperature set in. So we know it gets to probably about 45 degrees, maybe 50 degrees at 19 amps. But we'll prove that on camera. And then what we'll do is we'll wind it around there in a nice tight one level, so we don't get the massive bundle at the top. We have got a bit of wind coming down here, but that will affect both times. So it will affect it when it's all the way out, and it will also affect it when it's across there. Hopefully one day we'll get to do this inside and not outside down a windy alleyway. But we'll load it straight up with the hot plate, which we know is 2,500 watts, and the little heater, which we know is 2,000 watts. And that has gone up to 19 amps, as you can see. So we'll take a temperature reading at the start. So on the live, obviously we've got the neutral and the earth together, but you can see that the live is a lot hotter because it's only half of the load of the other two, or under more load, because the cross-sectional area of the neutral coming back is twice as big because we've got 2 cables compared to the live. So we're about 40 degrees there, and it says it's 7:15 on the thermal imager. So what we'll do, we'll come back in 10 minutes and we'll take a temperature reading, because we know that's going to stabilize, and then we can do the next part of the experiment. Right, so we're back. It's been 10 minutes. It's been very boring, to be fair. There is literally nothing has happened. We have got 39 degrees on the single live coming in, or 40 degrees coming there. We had 42 degrees at the start, so again, not much difference, literally a couple of degrees. And we'll test the midpoint, which was 37 degrees. And we'll just check that down there. And that is now 34 degrees. We are having a little bit, we are having the load keep switching off because the hot plate keeps on getting up to temperature and tripping out. Well, not tripping out, but cooling off. So we're going between 18 degrees and 15 degrees. But as Russ had said, it actually gives us a bit of a live test. The cable's warm, but not very warm. I need to stop squeezing it before it blows up in my hand. But what we're going to do now is we're going to literally reel this really tightly on here, hopefully increase the proximity effect. We've got our 2 temperatures now, which we're going to find out today if they dramatically increase. Whether it increases just here or whether it increases at the midway point, we'll find out. But we'll literally wind this up now, keep the same load. I don't think we'll run it through it. We'll turn it off. In fact, we'll turn it off now. Turn the 2 loads off, and we'll come straight back to 18 amps with it fully wound up on there. So yeah, we'll just quickly spin that round and get that on nice and tight. Okay, so we've got a nice tight coil now just there. As you can see, we have literally got the cables next to each other, and the electromagnetic effect should now, it may make it a little bit floppy. We should see a little bit of sagging, especially in this cable, but hopefully we'll get a massive temperature increase, maybe 150 degrees, I'm not quite sure. We'll load it up with exactly what we had before, which is 18 amps, to make this slightly more scientific than we can sometimes be. If it doesn't make a dramatic effect and we just get an extra 20 degrees, it's still interesting. It's still what we're looking for today. This is a mild science experiment, so we would like to actually see the proximity effect take effect, and not just blow things up, but then we will blow it up. So don't fear not. If it doesn't blow up the first time, we'll blow it up the second time. So straight up to 19 amps. Let me get the... So it's not making any difference there, obviously, straight away. Oh, hold on, look, if you come here, you can see it's nice the way that the cables are glowing. up to 42 degrees. So we're already obviously gaining temperature in the center, different parts. We're getting about 50 degrees now, certain areas. Just see if I can stabilize it. All right, 35. It's quite beautiful on there, to be fair. 37, 38. Right, it's saying 49 degrees now. So yeah, we'll leave that 5 minutes. The time is now on there 7:30, so we'll come back in 5 minutes and see how we get on. So that's the same amount of load, and at the moment we're 2 minutes in to the experiment. Still running at 18 amps. Just check up here, Russ. Still running at 18 amps. So we are getting a massive effect. I keep saying it's over 160 degrees. I just don't know if it is. We're actually getting a hell of a difference in the temperatures on either side of the coil. We're definitely getting a higher temperature from proximity effect than we did when the cable was run out. 60 degrees. Oh, let's have a look inside. Oh, look at the temperature in that. Looks cool. I think you get a truer reflection on this side. Look. So there is quite a massive increase, really. I mean, it's 65 degrees now, 66 degrees, about 4 minutes in, nearly 70 degrees. So it's running at its almost optimum temperature now. So, I mean, in conclusion, after 5 minutes, I would say that the proximity effect has taken effect, even just with that one line of cables as opposed to the bundle of cables. We are getting a massive increase in temperature. Well, I say massive, 20 degrees, it is quite considerable. Running at about 70 degrees at the top, or 69, 70. So I'm pretty certain that if we were to leave this or keep running this for a while, the cable would ultimately damage and eventually probably give way. It is being run. I mean, I can't really feel any temperature coming off of it at the moment. But yeah, so I think that what we have proven today, we have proven the effect of the proximity effect with just this cable being wound one time over. What we'll do now, though, is we will take it a little bit beyond that. We could leave it for 5 minutes and see. But to be honest, I don't think it's going to do anything else. So in conclusion today, for this part of the experiment, I would say that the proximity effect did increase the temperature of this cable by about 30 degrees. We went from 37 degrees there till about 70 degrees. Just check one more time here. We're only about 41 degrees here. Sorry, Ross, you can't there. 43 degrees, yeah, so not much difference. So the difference is actually localized in the coil. It hasn't transversed down the cable at the moment and putting pressure on that little bit of cable. But we're going to put the two big heaters on now, hopefully pump this up and get it to explode. So let's go. Okay, currently we're running at 12 amps, and obviously we haven't had a massive blowout. Got safety glasses on, Russ has got his glasses on. We'll go load it up with one heater there and the second heater there, and I don't think it will take too long. So what are we running at now, Russ? 40 amps. Okay, if you go that side, we'll see. Okay, we're about 88, 90 degrees now. I don't think that's going to take too long to explode. You can see the cable sagging. See the cable on the front here sagging now. 100 degrees. Still 40 amps pumping through. Getting to 115 degrees. We know from previous videos that 150 degrees is pretty much the magic number. As soon as we get to that, the cable just starts smoking, and then finally, oh, okay. So we had a very small pop. Right. I'll tell you what we did there. We just had a little tiny pop out here. I think what we'll do is we'll quickly get a bit of a twist on our cable where we coiled the cable up. Right, we'll quickly get that sorted. We'll get that quickly sorted and we'll start again with the bigger hopeful explosion. So we have sorted out the cable. We have given it a little bit of space. It was literally just those 3 cores there had touched together. Hopefully we don't. Right, it's gone straight back on. So good, we didn't actually blow the house this time. It is very warm. We haven't gone straight full for the full power just yet. We have got 18 amps going through it right now. So I'll turn one of the big heaters on. In fact, no, let's just go full whack. We're going 40 amps, 41 amps. We will, let's have a look inside because that was funky last time. 66 degrees in there. Cable's building up nicely again. 100 degrees. Seeing 104, put my safety glasses on. So we're at 114 degrees. Start smelling it now. The centre was getting absolutely roasting. 110 degrees in the centre. 140 degrees on the top. We're at the point of ignition now. It's 150 degrees. Yeah, smoking out. Oh, you can see it bubbling. That is roasting, look at it. Bubbling everywhere. Oh, good God, that's like 170 degrees. Maximum proximity effect right now. Look at that smoking. Absolutely stinks. Still, no blowout just yet. You could literally fry anything in the center of that cable reel right now. I wouldn't be surprised if it's just burst into flames. Another 2 minutes. Nearly 200 degrees. Oh, Jesus Christ. Jesus Christ. And in conclusion today, we could get maximum proximity effect at 40 amps, which isn't surprising, to be fair. We did have to push it. It absolutely stinks. And you can look at it now, it is just one continuous bit of cable. We didn't actually pop the house today. We did only just pop the 50 amps. We did pop 63 the other week. Look how melted it is. So yeah, so you can see the maximum effect of proximity effect today. It wasn't the big ball of flames I expected to go up into, because sometimes when a cable overheats, what it does is it takes all of its fire safety properties out and it literally bursts into flames like we had the other week when we just had the flame on the single cable. But that was still interesting. I don't know what we're going to do because that absolutely stinks. We're going to have to let it cool down. It's still 160 plus degrees in the center. Like I said, we should have fried an egg in there really, but yeah, no. A really good week. It wasn't the most dramatic, but again, at least we proved it a little bit better than we did last week. Hopefully the GoPro and hopefully the camera picked it up quite well. We won't find out until we have a look back, but yeah, it was really good. We did we did prove proximity effect this week. We got an extra 30 degrees off of a cable. When it was running about 37 degrees, we got up to 70 just by coiling it round. And again, not with much resistive losses because it wasn't bundled on top of each other. But next week, we will probably go to the bow wire. We'll do some extreme things with that. Not that you can do too much extreme, but it's very thin, so it shouldn't be too hard to overload. So we'll probably do some proximity effects and do other things. And then we might go on to doing some, we may well look at doing some eddy currents at some point, which we'll put through this little tiny fuse board here. We'll drill a hole in one side and then we'll have the cables coming out different holes inside, and we'll get maximum eddy currents, which will hopefully heat up. It might not be so dramatic. It might be if we get a blowout from one of the cables to the actual side of the metal, but what it will do is prove to us how eddy currents work, which might be quite interesting. Sorry it wasn't overly dramatic this week, but we will work on that. But this is, in a sense, a science experiment, so they're not always as they turn out. But yeah, I hope you enjoyed this week. Don't forget to subscribe if you haven't, because we get many people watching but not subscribing. So subscribe, like, share, comment. We love to hear what you've got to say. So thanks for coming this week, and we'll see you again next week.